Okay, let's go over some problems about solving equations. So your goal when solving any equation, well, if x or your variable appears in only one place, so there's only written once, then you should try to isolate that variable. But if it appears more than once, as it usually does, then no matter how weird your equation is, the goal is always to transform it into the form of a polynomial equaling a polynomial. Once you have it in that form, you then move all the terms to one side, so you have 0 on the other side, and then you either factor or you apply the quadratic equation. If it's quadratic, if it's cubic, there's also the cubic equation. You can have a computer do that for you. If it's quartic, there's quartic equation. If it's 5th degree or higher, you are plumb out of luck. You probably can only get approximate solutions. But let's see if we can do this one. So we want it to look like a polynomial equaling a polynomial. And it almost is, except for this 1 over x. That's not something that appears in polynomials. So how do I get rid of this? How do I get this to not be here? I don't like it. Well, fortunately, I'm allowed to multiply both sides of an equation by anything that I want. So what could I multiply by that would make this not be 1 over x anymore? Well, I could multiply by x. So that's what I'm going to do. I'm going to multiply both sides by x. Then I won't have x in the bottom of a fraction anymore. You need to be careful when you do this, though, that you distribute that x to every term on each side. So I'm going to do x times 1 over x, and I'm going to do x times 1/2 x. So x times 1 over x is just 1. That was the whole point, was to not have x in the denominator. X times 1/2 x is 1/2 x squared. And on the right-hand side, same deal, I need to distribute. So x times 1/3 is 1/3 x. And 3/2 x times x is 3/2 x squared. Okay, so now I have it in the form of a polynomial equal a polynomial. And I see that it's only a quadratic polynomial, so I can definitely solve this even if I need to use the quadratic equation. I have these fractions here, and I don't really love fractions when I'm potentially factoring. So at this point, I'm going to get rid of these as well, just because I can. So I want to get rid of the 2 in the denominator, and I want to get rid of this 3 in the denominator. So what should I multiply both sides by? Well, how about both of those? So 2 and 3, or in other words, 6. So that's what I'm going to do next. And I'm going to distribute again to each term. So everything needs to be multiplied by 6. 6 times 1 is 6. So 6 times 1/2 is going to be 3. So that's 3x squared. Over here, 6 times 1/3 is 2. This is 2x. And then 6 times 3 over 2 is 18 over 2, or 9. So this is 9x squared. Okay, so now there's no more fractions. I feel more comfortable. So I'm going to move everything to one side, so I get 0 on the other side. So I think the 9 here, if I subtract 3x squared, will leave me with a positive x squared. So I'm going to subtract negative 3x squared from both sides. And I'm also going to subtract 6 from each side. Okay, so everything over here is going to cancel. So I'm going to have 0. And on the right-hand side, I'm going to write it with the x squared term first. So 9x squared minus 3x squared, 6x squared. And then I've got this 2x. And then I have this negative 6. Okay, so now I've got it in the form of 0 equals a quadratic. I see that all my coefficients here are even, so I'm just going to divide both sides by 2 because I can. And that'll make it easier for me to factor. 6 divided by 2 is 3. 2 divided by 2 is 1. 6 divided by 2 is 3. So as I'm looking at this, I'm not sure if I can factor it, but let's see. And if I can't, then I'll use the quadratic equation, or the quadratic formula. Okay, so for factoring, 3x squared is going to be x and 3x. And then I need to factor my 3. So again, it's only can factor into 1 and 3, but I'm not sure if I should put the 1 with the 3x and the 3 with the x, or should I do the other way around, or will either of those even work? So if I put the 1 here and the 3 here, my outer and inner terms are going to be 9x and 1x, and I cannot get x by adding or subtracting those. So let me try the other way around. I'll put 3 here and 1 here. I don't think this is going to work either, because my outer term is going to be 3x, my inner term in the FOIL is going to be 3x, and I cannot combine adding or subtracting 3x and 3x to get x. So I cannot factor this. So then what I'm going to do is I'm going to use the quadratic equation. So if you want to memorize the quadratic equation, it goes like this. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. So this a is the coefficient on the x squared term, b is the coefficient on the x term, and c is whatever that constant was. So here we have a equals 3, b equals 1, and c equals negative 3. And we're putting those into this formula. So negative b is going to be negative 1. And then we have the plus minus. B squared is going to be 1. And then I'm doing minus 4 times a is 3. And then c is negative 3. Okay, this is good because at least now I'm not going to have a negative under my square root. And then 2 times a is in the bottom. So that's going to be 6. Now I simplify. So negative 1 plus or minus. Okay, so 4 times 3 times 3. Negatives are going to become positive. So this is 4 times 9. That's 36, I think. So 1 plus 36. And then all over 6. Well, so this is going to turn out with some... we're not going to simplify it into like an integer divided by an integer. It's just going to be this gnarly square root of 37 thing. Okay, so we have two solutions. Negative 1 plus square root of 37 over 6. And negative 1 minus square root of 37 over 6. My last step in all of these problems is always to plug in the solutions that I get to the original equation and see if they satisfy it. For this particular problem, it's kind of hard to do because this is such a yucky number. So what I would do is if you have a calculator, plug in each of these to your calculator to find what the two solutions actually are approximately, and then use your calculator to go back and plug into the original equation. So that's what I'm going to do right now, and I'm just going to pause the video while I'm doing some calculations. Okay, so the lesser one where we subtract is going to be, so negative 1 minus root 37 over 6. I just have a calculator on my computer here that I'm using, is approximately negative 1.1805. And then the other one is, when we add square root of 37, larger. This one is approximately 0.8471. So now what I'm going to do is plug those back into the original equation. I'm going to flip this over and I'm going to check these. So for x equals negative 1.1805, I'm checking this. And the original equation that's here is 1 over x plus 1/2 x equals, and now I'm questioning whether this is equal, so I'm going to put a question mark over it, 1/3 plus 3/2 x. Okay, and I'm going to just plug this into my calculator and check each side. Okay, so this is what I'm getting from my calculator. You see they're not exactly the same. This is 43735, this is 43742, but that's probably because I rounded off this number. So that's close enough to say that's checked. And I'll do the other one now. Okay, and this is what I'm getting for the second solution, which also looks close enough to call that checked. So these are the two solutions. So going back to my original answer, I would just go ahead and like circle or box. Yes, this was the correct answer. All right, let's do another one. Okay, so let's look at this example next. X plus square root of 2 minus x equals 0. So for this one, since x appears in more than one place, we can't just isolate it. What we need to do is try to make this into the form of a polynomial equals a polynomial. So right now, what's not polynomial about it is the square root. No square roots in polynomials. So we want to get rid of that square root. Well, to undo the square root, you can square. But you don't want to start by just squaring this whole side, because if you do that, you're going to be foiling this times itself, and you're going to have that outer and inner terms. You'll have more square roots in them. So you want to get the square root by itself on one side before you square. So what I'm going to do is I'm going to subtract x from each side. Okay, so it's going to cancel over here. So I'm going to have square root of 2 minus x equals negative x. And now I'm going to go ahead and square. So I'm going to square the entire side, each entire side. So on the left, the square and the square root are going to cancel out and give me 2 minus x. And on the right, I'm going to have x squared. So the negative gets squared and just becomes positive x squared. So now I have a polynomial minus a polynomial. So I'm going to get all the terms on one side, get 0 on the other side, and then I'm going to try to factor, or maybe I'll need the quadratic formula. So I'm going to move everything to the right. So I'm going to subtract 2 and add x to each side. And that's to cancel out this stuff. So I'm going to have 0 equals x squared plus x minus 2. Writing everything in order there so I can go ahead and factor it. And now let's see. Let me lay out my template here. So for the f of the FOIL, I need to get x squared. So I better use x and x for my first part in each parenthesis. And now for the L of the FOIL, I need to get negative 2. So I'm going to need to do 2 and 1, and one of them will be positive, one will be negative. But I never worry about the sign until the end. I guess we are at the end. So now let's see, which one do I need to put the negative on to get x for my outer and inner? So 2x and 1x. I need the 2x to be positive and the 1x to be negative. So it'll be like this. Okay, so I was able to factor it. Since I was able to factor it, I'm going to go ahead then and use the zero product property. Zero product property says that if something times something equals 0, then one of those somethings must have been 0. Because I never get 0 when I multiply things together unless one of the things I multiplied was 0, right? If you multiply a bunch of numbers that are not 0 together, you'll never get 0. So now I'm going to set each of these equal to 0, because that's the only way I could have gotten 0 here. So x plus 2 equals 0, x minus 1 equals 0. Okay, and then just a very quick solution here, x equals negative 2 or x equals 1. So I think these are my two answers, but I need to actually go back and plug these into my original equation, just to check that those really did satisfy the equation, especially because there was this step here where I squared both sides. Because the thing is, it's possible to take two numbers that are not equal and square them, and for them to become equal. Like negative 1 and 1, if you square them, they become equal. So squaring both sides could possibly have introduced a wrong solution. So I'm going to check and make sure by plugging these in. I always do this anyway, it's just standard last step. So first I'm going to check x equals negative 2. I'll just do this in 2 columns. So x plus root 2 minus x. I'm checking if that's going to be equal to 0. So I'm going to plug in negative 2 plus root 2 minus negative 2. Let's see if it's 0. So simplify each side separately. Don't try to apply algebra because you're checking whether you did the algebra stuff wrong or not. So don't recreate mistakes down here, just simplify. Or use a calculator. So this is going to be square root of 4. And then, yeah, okay, so negative 2 plus 2. Yes, this is 0. You can see. All right, so that's a good solution. And then my other one, check x equals 1. So now I have the equation here, so I'll just plug in over here. So 1 plus root 2 minus 1. Is that 0? Oh, yeah, I think. Oh, interesting. Yeah, interesting. It's not. Yeah, it's not. So 1 plus root 1, that's not 0. Yeah, fascinating. So actually we did discover that this is not a solution. It does not satisfy the original equation. So the only solution here is this one. So what happened, I think, is at the point here when we had it in this form, like right before we squared it, if you would have plugged in 1 here on the left side, you would have had a root 1, which is 1. But on the right side, you would have had negative 1, right? But then when that got squared, boop, boop, 1 and negative 1, after you square them, down here, they're the same, but not in the original equation. So that's why you always got to check. All right, let's try another example. So this looks kind of similar to the first one. I have an x in a denominator. It's not very polynomial-like. So I'm going to try to not have that anymore. So to get rid of something in a denominator, I'm going to multiply both sides by that thing. So be careful that you get the entire side multiplied by whatever you want to multiply both sides by, which means you're going to distribute it over both terms there. So this is going to be 2x squared on the left, and on the right, when I do 3 over x times x, that's just 3. That's the whole point. And then 5 times x is 5x. Okay, so this looks like now it's a kind of standard quadratic. So I'm going to subtract minus 3 minus 5x from both sides. That will cancel. And I'll have 0 on one side. And I'll just put the terms in the standard order so I can do my thing. I'm going to try factoring. If it doesn't work, then I'll use the quadratic formula. So 2x squared is going to be 2x and x. And then for my L of my FOIL, I'm going to have 3 and 1. But I don't know, should I put it here? Or should I do 1 and 3? So if I do 3 and 1, then my outer and my inner for my FOIL are going to be 2x and 3x. 2x and 3x, yeah, I can make negative 5x from that, I think. Maybe. But only if I add them together. And since I have negative 3 here, I'm going to have to do a plus in one and a minus in the other. So I don't think I can actually do both minuses, which is what I would need for negative 5x. So let me try the other way around. So put 1 here and 3 here. Let's see if this works. So my outer and inner will be 6x and 1x. Okay, now I can make 5x. So one needs to be positive and one negative because we have negative 3 here. So to get negative 5x, I need negative 6x and positive 1x. And that should do it. So now to finish up the solution, I set each factor equal to 0. So 2x plus 1 equals 0, and x minus 3 equals 0. One of these has to be 0 because their product is 0. So now I'm just going to do a quick solution. 2x equals negative 1, x equals negative 1/2. And over here, x equals 3. So now I want to go back to the beginning and plug both of these into the original equation. So check. X equals negative 1/2, and check x equals 3. Okay, so my original equation was 2x, and I want to see if that's going to be equal to 3 over x plus 5. So first I will plug in negative 1/2. So this is 2 times negative 1/2, 3 over negative 1/2 plus 5. This is a question equals, because I don't know if these are equal yet. 2 times negative 1/2 is negative 1. I'm glad I got an integer. And over here, 3 divided by negative 1/2. So when you divide by a fraction, you take the reciprocal of the fraction, flip it upside down, and you multiply that by the top. So this is really 3 times negative 2 over 1, which is actually just negative 6. And when I add 5 to that, I do get negative 1. So this is equal. So yep, that was a good solution. And let's try the other one, 3. So this is going to be 2 times 3, question equals 3 over 3 plus 5. Yeah, this is 6, and this is 1 plus 5, so it's 6. So these were both good solutions, and so I'm going to circle or box both of these for my final answer. Let's do one more. My cat has joined us for the final problem here, so he's going to try his paws at this, and we'll see how it goes. All right, so I have a fraction equals a fraction, so I'm always going to cross multiply in this situation, which is really the same as just multiplying both sides by both denominators. So I'm going to have 1 times 3 minus x equals x times 2x plus 3. And now I'm going to distribute each side. So 1, that doesn't do anything. So it's just 3 minus x. And then over here, I have x times 2x. Can you guys hear my cat purring? He's very happy about this quadratic. So this is going to be 3x. And he's actually trying to climb. He's trying to put his head, oh my goodness. You know what? I'm just going to leave this in. I'm just going to leave this in. Okay. All right, buddy, settle down. I know, I love quadratics too. Okay. So now I'm going to move all the terms to the right-hand side. So I'm going to do that by subtracting 3 and adding x. Okay, so these cancel. I get 0 on that side. And then on this side, I have 2x squared plus, let's see, I have 3x and another x, so that's 4x, and then minus 3. Okay, so now I'm going to try to factor, and if I can't do that, then I'll use the quadratic formula. So let's see. Okay, so 2x squared is going to be 2x and x for my f of my FOIL. For my L of my FOIL, I need to get 3. So I'm going to do 3 and 1 or 1 and 3. I'm never sure which it's going to be. Let's try 3 and 1. So for this, I think my outer and my inner would be 3x and 2x, which I could get either 1x or 5x, but I can't get 4x. So let me try the other way, and I hope that works, because otherwise we're doing the quadratic. So 1 and 3, so that would be 6x and 1x. Nope, I cannot get 4x from that. Okay, so we're using the quadratic formula. So my a is, the x squared coefficient is 2, b is 4, and c is negative 3. So here's the formula again. See if my cat likes my singing. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so now let's plug in the little pieces and parts. So negative b is negative 4 plus or minus. B squared is going to be 16. 4ac is going to be 4 to negative 3. Okay, at least I'm going to have a positive number inside the square root. Okay, the cat has exited the equation here. He's getting too rowdy. 2 times a is going to be 4. All right, let's see if we can simplify this. So negative 4 plus or minus 16, and then we've got 4 times 2, that's 8, times 3 is 24. And the two negatives multiply together to make it positive. It looks like 40, so I don't think that's really going to simplify much. But maybe we can take a little bit of a simplification, because this is 40. then that's 4 times 10. So I could at least take a 2 out of the square root. Okay, so what I'm going to do here is this is negative 4 plus or minus, this is square root of 4 times square root of 10. So square root of 4 is 2. All right, and then, so this is negative 4 times, or sorry, plus or minus 2 times square root of 10, and that's all over 4. So I can cancel a factor of 2 from the top and the bottom by factoring out a 2. That would leave me negative 2 plus or minus square root of 10, and then on the bottom 2 times 2. So I'm going to cancel a factor of 2 like that. Okay, it doesn't really help me very much, but I should do everything I can. Wow, I went all the way through a piece of pencil lead. Okay, so my final answer here that I'm getting is negative 2 plus or minus square root of 10 over 2. Okay, so now what we need to do is, because it's got those square roots in it, I would put that into a calculator and get both approximate solutions. And then I would go back to my original equation here, plug into both sides, and make sure that it's still equal. I don't really anticipate any problems, only if I made a mistake. But I'm going to let you guys imagine me doing that on your own. And I will go ahead and stop the video here.